Okay, sir. Very good morning, and you are looking very handsome today.
Thanks for the compliments.
Sharma ji is also with us, sir.
Good morning, Sharma ji. Good morning, and thanks for giving me this opportunity to be with you and such learned audience, which have great composition of working engineers. I hope to have an interactive discussion. In fact, for a person like me, it's very difficult to be, talking, deliberating online, because I'm used to of more of interacting sessions than teaching sessions. We are not academicians, but still I'll try to do justice with the duty you have assigned to me. Please let me know as to how would we interact. Would it be two-way interaction, or I'll finish the talk and then they'll?
I think that will be better. You finish the talk and then we can ask the participants either go on the chat box or they can basically ask the questions. Raise hands or maybe unmute their mics one by one and they can then ask the questions.
How many audience we have as of now, and do we need to start or what?
Yes, we can start. Already 14 people are registered. We already put the message on WhatsApp, so most other people will be joining within 4 or 5 minutes. So we can start with our session. And let me introduce our today's guest faculty. We have with us yes, Saini, who is representing hospital engineer in PGI, one of the premier institutions in the northern part. I think everybody knows about PGIs. And he is basically carrying out lot of developmental and works in PGI with respect to new projects as well as with respect to upgradation of the say their existing buildings. And now I think one of the recent building they have made, that is the first hospital in India to be rated as 5-star building by Griha. By Griha, or I think it is IGBC. This
IGBC Platinum.
IGBC Platinum building. So, and I was basically instrumental associated with that building in carrying out their third-party audit. So I have seen the construction of the building right from their foundation stage up to the finished level, and I know that okay, this is one of the best building, and many of the initiatives they have taken, smart initiatives they have taken there for the benefit of the patients. Like online reports and many other things are there. So I think that is what Saini Saab has said, that he is not a academician, but the project he is associated is one of the unique projects, particularly for smart hospital and smart hospital management. And I think that you all will be benefited. I will request you all kindly attend very carefully, and then after the end of the question, you may interact with it. It is not a asking question or something like that. It is only that okay, you can interact with our experts, and whatever the basically your queries are there, your say some queries with respect to say clarification, so that things can be discussed with the experts. So I will request you kindly be interactive with our this thing, because that motivates the speaker also. Basically, if you are just listening, so that is not going to like motivate our this thing also. So kindly I will request you all that at least you basically interact with the experts. So thank you very much, sir, for sparing your valuable time today. And you can start our presentation. You can share your presentation right from by going down the screen together now.
Thank you.
Kamal, can you guide? Sir, it's visible.
Yeah. So I'm audible also.
Yes, sir. You are perfectly audible. Perfectly audible, sir.
All right. So thank you so very much, friends. So I would be talking on smart hospitals. lending technology-driven healing touch. Uh, so I go back to the discussions which you have been having for last couple of days, and that's smart city. So I hope you are all aware what is a smart city is. A city that has sustainable development and high quality of life by way of economic, mobility, environment, housing, utility, and governments using ICT is the one of the definitions which I could find for smart city. So, friends, when we talk of smart city, you would see at the first very line, it is city that has sustainable development. So, friends, what is sustainable development? Sustainable development is the development that meets the need of present without compromising the ability of future generation to meet their own needs. Meaning thereby, it's a development wherein we preserve the natural resources. We attempt not to make depletions to the ecology of the area we are working. It encompasses three basic and interrelated objectives. It is economic security and prosperity, social development and advancement, and environmental sustainability. As you all might be knowing by now that the basic elements of smart city are smart energy, smart transport, smart water and waste, smart social, smart buildings. I would like you to concentrate on smart energy, smart water and waste, smart buildings. Smart transport, smart social would not be that relevant in hospital environment because it will be a small campus, small transport area, but still we have transportation facilities, smart transportation facilities like pneumatic tube system for transfer of samples and bills and charges, etc. And smart buildings is what we are going to be discussing. Again, the smart city solutions are energy management, water management, waste management, mobility, e-governance and citizen service. For hospital environment, it would be reporting, digital report communication, digital archiving of the various parameters and diagnostic reports and all that stuff, billing, appointments, mobility, again, as I have already discussed. So what constitutes smart healthcare? The smart healthcare combines and leverages smart systems within home, hospital, patient information exchange and existing data with consideration to integrate into larger schemes. The ultimate aim of smart healthcare is unifying the total healthcare system. It's just a start. We have to fit into smart city as a module, and ultimately it will combine to smart nations, wherein the data is leveraged for city planning and population management, providing a roadmap for the future so that we are able to control, monitor, and facilitate our population well. So what is smart healthcare? How are we moving towards smart healthcare? What are our goals, ultimate goals for smart healthcare? So from traditional healthcare system, wherein we have disease treatment or patient comes to a hospital after he gets some disease or ailment, and then he is treated. We have to shift from disease treatment or curative care to preventive care, wherein we look after the well-being of the patient beforehand, meaning thereby even before he acquires a disease, he is diagnosed and preventive care is taken, so as which would result in lesser number of people approaching hospitals. And ultimate aim is I am able to pinpoint and provide a personalized healthcare to a person. As you know, the same treatment given to different people would yield different results. If I am getting a paracetamol 650, it may have a different potency effect on me and different potency effect on you. So ultimate aim is to move towards a personalized health management system. As on today, we are treating a particular patient in a hospital. From here, we want to move to interested parties or groups of the societies, and then ultimately to anybody who would like to be getting associated or treated in a hospital, be it preventive, be it curative, be it wellness, be it anything of that sort. As on today, we have fixed timings in hospital environment, wherein for OPD, a patient comes maybe 9 to 12 for registration. The blood testing closes at 2 p.m. and so on. We would like to shift to anytime treatment, anytime, anywhere you are comfortable, be it at night 11, you go and drop your blood samples, and at 2 a.m. in the morning, you get a report on that. That's the aim. And now, from the fixed place acute care hospitals, we want to have modules, mobile modules, wherein I am able to treat patient anywhere, anytime. You are not required to be shifted from, like, if you are living in a state of Himachal wherein it's snowing this time and you are not able to come out, you are required to be shifted to helicopter or those kind of things. So that should not be there. Through telemedicines and teleconsultation, I should be able to treat you there, and through my nearest mobile service, through GPS, I should be able to monitor that and send it to you in the time of need. That's the ultimate smart healthcare we dream of. And these are, of course, the components. So to achieve anywhere, we'll have to utilize network technology, sensor technology, home care services, and for any time data processing, as I was talking, expert system technology and all that. And ultimately, we would achieve a society which is healthy, which has a longevity of life compared to what it is today. Of course, ICT integration has a major role to play, as I've already discussed. I would like to spend some time on the National Health Policy 2017, which has come up, and its ingredients. Friends, let me share with you the focus of the policy has now shifted from let me read out the excerpts from the policy, which says, to achieve the highest possible level of good health and well-being through a preventive and promotive healthcare orientation in all developmental policies. Next. The government aim has shifted from sick care to wellness. Let me tell you, number of wellness centers have been created in the country, and they are in the process, wherein when you go to a community center, district level hospital, you would find that it's not medicines or diagnostic treatments which are being carried out. There are wellness areas which have been created, wherein you'll have interactive sessions about dietary habits. You will have introductory sessions about yoga, benefits, how to cure your type 2 diabetes, and all those lectures. So Government of India has shifted from sick care to wellness and promoting prevention and well-being instead of curative care. So this is what it is. Another thing which I wanted to share was that how are hospital different than all other buildings, which are which are offices, schools, institutions, and other buildings. First of all, hospitals are 24/7 operating buildings. There is no rest. Every hospital engineering service has to operate 24/7. You'll have to have adequate redundancy to take care. Inmates are incapable of self-preservation. This is very important, meaning thereby the safety and uh, fire safety, you have to be very careful. In case of fire, the inmates who are bedridden are not able to, carry on self-preservation or move by themselves. So what we need to do, instead of applying routine evacuation techniques, we'll have to have facilities for horizontal evacuation. So if you look at NBC now NBC provides for a fire partition on each floor plate of a hospital, wherein it facilitates the horizontal evacuation in case of fire, apart from those specific dedicated areas where you collect yourself during fire. Healthcare facilities have unique systems, such as they have diagnostic machines right from MRI to CT to PET, analytical systems. You have medical gases which are very prone to risk. Oxygen, if found excess in environment, can be catastrophic when you switch on your electrical system. You have modular and integrated operation theaters which have come in. So you'll have to very differently deal with those areas wherein these equipments are installed. Let me share with you that an MRI, if has electromagnetic interferences around, would not be able to give you the right results. So what we need to do is we create a electromagnetic interference, anti-electromagnetic interference grid around the area where we install an MRI. So different areas of equipment installation would have different engineering requirements. There are that's why there are special provisions for construction of hospitals in codes and regulations, as I was narrating you about the National Building Code. So what is smart healthcare facility? WHO has developed a tool for smart healthcare facilities, and that tool says that if you have a green and safe hospital building, it's a smart hospital. I go beyond this, as I was discussing. If you have a green, safe, and accessible, you would know that in India, Person with Disability Act has been enacted during 2016, and now all buildings have to have universal access available. So green, safe, accessible, ICT integrated, and compliant to national health policy. So whatever we develop, whatever we build in the name of a hospital should be also complying to the national health policy, meaning thereby it has the ecosystem of the whole hospital should be congenial to not only patients but also the people who work there, the employees, and the doctors as well. So what we recommend? We recommend go for green rated building construction, integrate ICT while planning, and create universal accessibility. You would have a smart hospital in hand. So how do we do that? Before that, I would like to share with you certain benefits which are established through various studies about green hospitals. They enhance daylight. You know, researches have been carried out in country and abroad that with the proper adequate daylight, the recoveries are faster by 15% and patient stay is reduced in the hospital by 41%. Better connectivity with the nature outside reduces patient stay by 8.5%. Improved health and hygiene results in better infection control. The smart hospitals give you energy saving to the tune of 30 to 40% and water saving to the tune of 20 to 30%. Water saving can be as much as even 50% with water efficient fixtures installed, as against the conventional hospital which would consume around 260 to 275 kilowatt hours of energy per square meter per year. The green hospitals would consume less than 180 kilowatts per meter square per year. And we have in our institute 2 of such buildings which follow them in this range. And recently, as we have that IGBC platinum rated building that is sub 150 kilowatt per meter square per year. So you can imagine the kind of cost saving on account of energy cost which you would gain. But it's not the energy or cost saving, it is the environmental impact also, which reduce the carbon footprint is reduced if you utilize a energy saving technology. So what are the elements of smart hospital? So smart hospital would have habitable spaces which are smart waiting area, examination room, inpatients, out OPD, engineering infrastructure wherein we would have applied the latest technology, and of course ICT as I was talking. So what's a green hospital? A green hospital enhances patient well-being, adds to curative process. It provides healing environment for faster recovery of patient. It eliminates sick building syndrome. I hope everybody is aware sick building syndrome is a syndrome wherein inside a conditioned building, when you do not get adequate air ventilation, adequate quantity of fresh air being pumped in, adequate control of temperature and humidity is not there, you get giddiness, you get headaches, and you get all kinds of disease syndromes, and that's what is known as sick building syndrome. So a green hospital reduces stress level in hospital working. It provides healthier spaces, as I was talking, and most importantly, it reduces hospital acquired infection. How we would come to know in the later slides. One example I would like to give you here. How does it provide healing environment for faster recovery? Friends, I don't know whether you are aware or not, but then there is effect of color, temperature, and the intensity of light on human body. For all of you who are not aware, color temperature is the temperature of light which is installed, the lighting fixtures which we have. A color temperature of sun for that matter is 5700 degrees Kelvin. And the color temperature varies from 3000 degree Kelvin to 6000 degree Kelvin, and depending upon this it is utilized for various, for certain operation you have to have a specific color temperature to see inside the body or stomach. If you want to see the liver, you'll have to have a different color temperature, it gives you different light reflection, and that's what is called color redundancy index. So hormone production is also light dependent. If I am able to manage my lighting, illumination, and color redundancy at par with what is existing in environment, I am able to give a great relief to the patient who is contained in a room inside a hospital, and enhances it enhances the patient recovery time. How? Because there are certain hormones which are generated depending upon the color temperature in the body. So if in my body at 11 p.m. in the night, if I do not have melatonin generated, which allows me to go, which provokes me to go to sleep, refreshes body, enhances feeling of comfort and relaxation, and instead I have serotonin being generated, which facilitates sense of well-being and activity, then I would not be comfortable. So if I am able to somehow manage my clock, biological clock inside the hospital room, I'll be better comfortable and my recovery time would enhance. Considering this, in one of our recent hospital buildings, which Dr. Sharma was stating is IGBC platinum rated, we have installed circadian lightings wherein we change the intensity and color temperature to provide to match up with the outside environment and provide comfort to the patient underneath. So I would come back to the same thing as I was talking. So how to go green? To go green, we need to register for a green rating system, which can be led by US Green Building Council, which can be IGBC, by CII, Confederation of Indian Industries. We have GRIHA, Green Rating and Integrated Habitat, by TERI. CPWD also has its own rating system, and GEM is also having one rating system. Compliance to these rating systems require application of national standards and codes such as NBC, ECBC, Ministry of Forest Regulation, CPCB, CCCB compliance guidelines, pollution norms, and you get all compliances in one package. That also is very important to make your building smart. So different rating systems are available. One rating system which we followed in this building was IGBC rating system, and similarly I have placed GRIHA along with it. What I wanted to share with you was that different rating systems have given different weightages to different aspects of sustainability. While the IGBC rating system, which has a specific module for healthcare facility assessment, they have a specific rating module for assessment of hospitals, and while they give highest weightage to indoor air quality and sanitization and hygiene, the GRIHA gives highest weightage to energy, followed by water and site planning. So while we are choosing the rating system, also we need to do some research and choose the right kind of rating system. Now I would shift to some initiatives taken by PGI in moving towards a smart hospital, and I would share the details. For going the smart way or the green hospital construction, it all starts when you conceive a project. You cannot make a building smart once it has already come up and shell is there, and now you say that I would like to make this hospital smart. It's not going to happen. For smart, you'll have to start thinking and planning from the beginning. Master planning stage. So in our case, we started with the master plan of the PGI. I'll give you an example. Why do we need that? For a hospital design, you need to have a piece. Once you get a piece of land, you need to go for zoning. What would you like to be constructed where? Should be all thought of. You should have institutional and hospital area on one side and residential area on the other, as you can see in this slide. And in the hospital is on one side, along with trauma center. Services are separated out towards the boundary. Ayush and Herbal Garden is a isolating buffer between the medical college, nursing and auditorium, that is institutional zone, and thereafter in the end, after another buffer, we have hostels and residential. This is master plan layout of one of the aims like institutions coming up. So we have to it has to be a well thought approach to go smart. We need to know the stack diagram as to what we are going to be placing at what levels. We have so much so that the NBC has now stated that you cannot have operation theaters beyond 30 meters. So you'll have to place them accordingly. OPD and diagnostics should be at the ground level, so that they are easy to access. They have heavy equipments to be installed, as I was talking. So they have to be at ground level. Then we should have teaching, then what, and that this all has to be well planned. While planning and designing, you need to be utilizing the latest tools for hospital construction. Friends, I am sure you would have now be knowing that for building design, after AutoCAD and SketchUp design tools which were in use earlier, now building information modeling has come up. Building information and modeling is a digital representation of physical and functional characters of the facility. It's an answer for well-planned, innovative design. You know, the better we are able to plan and take our services, the smarter we are in operating later on and maintaining them. BIM integrates both building model and information model in systematic way. This is one of the building designs utilizing BIM, wherein different teams work: air conditioning team, construction team, mechanical team, electrical team. As you know, healthcare services or hospital are the structures which have the maximum number of engineering services built in a complex manner, and they often clash with each other. So what do we do through BIM? Through BIM, we design a 360-degree approach. We have 3D modeling wherein different teams are working together, and they are identifying clashes, modifying, and they are able to access it from anywhere on their laptops, computers, and those things. So this is through BIM we can carry on structural analysis, human analysis, solar analysis, and even we can augment to reality. This is laying of air conditioning ducting system in one of the hospitals. You may see that how complex scenario it is, and through BIM I am able to identify that blue oval duct and its routing, which generally I would not be able to imagine if I do not have 3D image in front. So 3D BIM images help in visualizing inter-services crossovers and clashes, which result in optimal utilization of available service space, which are always scarce in any and especially hospital buildings. So in our institute, We have divided the institute into two zones. The yellow part is residential zone, and the right hand side, which you see, is our institutional zone, wherein we have different institutional buildings coming up. This is another view, and this is what is our 250 bedded expansion of Nehru Hospital, which is a IGBC Platinum rated building. I would like to share with you certain features of the building, or how have we attempted to go green and get this rating, which would actually make this, which has actually made this building a smart building, and in turn a smart hospital. This is a G+4 building, 25,000 square meter area, built up area, 22 meters height, and it houses 4 of our departments: oncology, ENT, hepatology, endocrinology. It has heavy equipments like linear accelerator. We have state-of-the-art modular integrated OTs. We have installed pneumatic tube system for transportation of reports and samples. We have ECBC compliance glass and facade glazing and insulated external envelope. So we have adopted IGBC rating, which has broadly 6 parameters, and I would like now to share how we were able to achieve these parameters. One is, and the foremost, as I was already talking, is that indoor environment quality and well-being, under which these are subheads like minimum fresh air and ventilation, tobacco, smoke control, healing, architecture, and all that stuff. I'll go one by one within the limitations of time, and I would like to touch upon broadly the important features, or the features which are unique to these buildings. No, I will not be spending time on all these slides. If that be so, we would request Dr. Sharma to give us time some other time, wherein I'll explain you all what are the parameters and how we have achieved that. So to begin with, there has to be a minimum air ventilation in the specified spaces. Friends, this is very important for a hospital environment. Generally, we follow ASHRAE 170-13 standards for comparison. This is ASHRAE is American Society for Heating, Refrigeration and Air Conditioning Engineers, and they have made certain standards of ventilations inside hospital areas. Like for operation theater, it has to be at positive pressure compared to adjacent area. The minimum outdoor air changes should be 4 minimum. Total air changes shall be 20. No exhaust is required, and relative humidity also need to be controlled between 20 to 60%, and temperatures 20 to 24. So these are minimum basic parameters. Friends, you would appreciate that once we adopt, no other system or norm in the country or bylaw, building bylaw in the country tells you to ensure such things. As you remember that I was talking of sick building syndrome. If we adopt a rating system and if we adopt these ventilation norms, we would never get into the sick building syndrome anytime. And so this is how we were required to have minimum air changes, 2 air changes per hour as per ASHRAE, and we have achieved through exhaust fan in toilets, return air ducts in critical care areas, and addition of fresh air through AHUs. This is how it is. The air vents inside a room, the air collected is passed on to ventilation ducts and ultimately exhausted. The required percentage of air is exhausted. So cross ventilation, The norms require 50% regularly occupied area shall have openings to outdoor environment. Yes, you could see that this is one of our wards, and we have 1/3 shutters which we have installed in the windows are openable. Generally, in air-conditioned building, we make them airtight, but it should not be so for two reasons. One is that you have to ensure that 50% occupied area are opening outside, for the reason that in India, you do not have those AC requirements throughout the year. So when it is lean time like this time, you can open windows and get away with the air conditioning even during this environment, and you require a specific amount of fresh air, which you can of course add through AC system also. Another reason why should you have the openable windows is the norm, the fire safety norms, which now have been incorporated in NBC 2060, also call for openable glass glazing after every 5 meters or 10 meters or so. The tobacco control, we have signages. So healing architect daylit spaces, the norms require us to, the rating system require us to show 50, could you go back? 25% regularly occupied areas achieve daylight illumination of minimum 110 lux. So how do we achieve that? I'll show you. In our case, we have 83% patient room areas which achieve the daylight, and 56% of the total areas which achieve daylight. Friends, you are aware that sunlight is is very important. It itself kills bacteria and viruses, so we must have sunlight entering in. When we construct our home, we also ensure that we should have sunlight in certain areas, and we prefer sitting our sittings there. So how do we achieve this? We achieve this by orienting our building in such a manner that the sunlight enters wherever we want it to, and we are able to avoid sunlight where we do not want. High sun contributes to solar gain, and this south facade have deep recessed window shading devices. If we are able to provide, we can utilize the sun glare sufficiently for daylight, and all wards and all those areas are on this side of the building. So if we orient the building proper and plan the areas with respect to the orientation of sun or the sunlight, by doing this solar analysis, we are able to manage infection control in hospital in a very good manner. And by constructing such construction, like in our case, E-shaped building, wherein one of the blocks is providing shading to the other blocks, and we are able to then, utilizing these passive measures, we are able to save energy as well. So for providing daylit spaces, we have provided specialized glasses also. These are double glazed insulation glass units. We have average lux level of, we have achieved average lux level of 220. We have utilized the glass which has light transmission of 27, external reflection 16%, internal 19, and U value of 1.6. You can see the simulation which shows the yellow light is the maximum, the yellow area is maximum sunlight, and the blue area is minimum sunlight. Next. see the how our hospital is well lit by the daylight. So connectivity to the nature, as I was already talking, the criteria demands show 25% regularly occupied areas are connected. We have achieved 60%. You can see the nature from is available for view from windows and most of the beds in the hospital. Then through passive architecture, it demands us to show that 2% energy saving is there. As I have already explained through this applying these simulation approach, passive architect, we have been able to achieve 2.3% as against 2%, as I was talking in the last slide. Next. I may add here that the external walls of the building are with cavity filled with the glass wool insulation of 25 mm and aerated concrete blocks on both sides. So then it talks of green open spaces, which we have a lot. This all green area you can see in the layout is green open spaces. These are some pics of open spaces which we have created around the hospital building. We have utilized 119 trees there. Healing garden is also part of it. Another aspect which I wanted to actually share was the color psychology. Many of us, while designing and the buildings and painting them, do not bother about the combination of colors we use. You must have seen some places you visit, the colors are very harsh and not soothing to the eyes. So there have been researches, and they have come out that certain colors are very congenial for treatment of certain diseases. Accordingly, we have applied different colors psychology also into our building. So this is our cancer section, wherein we have purple. This is our hepatology section, where we have light yellow. The modular OTs which we have installed, you can have a view which is integrated modular OTs. We are able to do all communication and archiving from inside the OT shell. This is a stainless steel OT shell, and you can see that we have provided it with blue, all blue. I'd like to share another photograph which is not from this hospital, but one from one of our MRIs area, which is for kids, and we call it up to 10-12 years of age, and we call it kitten MRI. So to make the children who come for diagnosis, we make them familiar before they actually enter into MRI, and these are the colors we have tried to create to provide them comfortable when they go in actual MRI environment. This is about color psychology. Now, an acoustic design, most of us don't bother about acoustic in our country, whereas there are norms which have to be followed as per NBC also, and in this GRIA rating also they wanted us to follow certain norms. So we have been able to achieve a background noise level of less than 40 dB and reverberation time of 0.49 to 0.7. For your information, reverberation time is the time for sound in a room to die down. So this we achieved by acoustically treating our air handling unit rooms and providing acoustic panelings into our seminar rooms and office spaces. This is NBC requirement. Hospitals fall in silence zone, and it has to be in daytime below 50 dB and nighttime 40 dB. Friends, if we don't bother about this, then we would end up in situation like this where Mumbai has introduced a traffic management system. If your honking and sound level is more than a certain level, the light would not turn green. So if you honk more, you would have to wait more. Why why go for these situations? Why not plan your buildings? Why not plan your areas that you do not have acoustic issues later on? So this is one of the side photographs when we were constructing. You would see glass insulation, wooden slats, acoustic wooden slats being installed, and it shows 40.5 dB. These are some views of our seminar rooms and classrooms. So our furniture is also ergonomically designed as per the requirement of the rating system. Um, I'm sure most of us, when we work for hospital design, construction, and procurement of materials, we don't furniture. We don't look at ergonomic aspects. And if I have to share what is ergonomics, is then in its most simplest form, ergonomics is the process of designing and arranging the workplaces so that they fit into the people who use it. So ergonomics aims to create safe, comfortable, and productive workplaces by bringing human abilities, limitations into the design, human abilities and limitations into the design of a workplace, including the individual's body size, strength, skill, speed, sensory abilities, and even attitude. So we have procured this furniture from Godrej, which is not only ergonomically designed but also green rated material. Next. The body and embodied energy of the material is very less, and it has IGBC grain rated stamp on it. Next. So as per the rating system, we have to provide stress relieving spaces. So we have given them indoor spaces for that. Chest rooms, cafeteria. We have utilized, as per the requirement, low VOC paints and materials, no urea content. This is what we have used. Another important aspect is air quality monitoring and testing. So we have installed temperature, humidity, VOC, particulates, and CO2 monitors. We carry out all these parameters to our BMS system and we analyze. These are some sensors installed on our air handling units. Next is sanitation and hygiene. So we have to be working in a hygienic manner in a hospital. The in thing today is automatic waste management system like pneumatic tube system. Though we could not do this in our building. We are using proper biomedical waste disposal containers. As we are all aware, hospital-acquired infection is another important aspect, and hospital-acquired infection varies in Indian hospital from 8% to 10%, and as per WHO study, in 14 countries it is 8.7%. So how to control? As we have seen in earlier slides, we have to follow air ventilation rates. We have to follow filtration also. We have to carry on purification, and antibacterial surfaces are something which you can now utilize. Copper is supposed to be a great antibacterial surface, and now you can have doors and handles, all that stuff of copper to avoid bacteria and viruses growth over it. So the strategies are antibacterial surfaces, as I was talking, copper, filtration. So different levels of filtrations are there from right from micro-V filters to HEPA filters or MERV 14 filters, wherein you are able to filter out 99.97% up to zero point 0.3 micron, in which range almost all bacteria and viruses fall, and you are able to do away with them. Dilution is the best solution, as we all know, and as I was talking, requisite air changes and ventilation rates, if you are able to maintain, you would not have those infection issues. With this current COVID pandemic scenario, you have to have more fresh air pumped in, so that the chances of bacteria load is less. Adequate pressure level differences and purifications through UV lamps and other chemical techniques can also be carried out. In our case, for infection control, instead of normal filters, now this time we have installed central air cleaners, which are very highly efficient in reducing 2.5 PM 2.5. The great advantage here is that it does not only not only traps the area as like in other filters, it kills the bacteria and viruses. It entraps. It has a low pressure drop, which results in lesser rating of motor for AHU, and ultimately reduction in energy consumption. Along with this, we have carbon filters also, which reduces VOC and odor entering into the main hospital areas. So this is one of the photographs. We follow standard sanitation and cleaning practices. Green chemicals we use. As regard to energy efficiency, the IGBC rating requires us to use ozone CFC-free refrigerant, non-ozone depleting substances. So we have used, instead of halon, we have used HFC 227 for fire extinguishers, and we have used non-CFC 134A refrigerant in our refrigeration chillers, which is also non-CFC. We are able to achieve the ECBC baseline. This is a comparison which has been made. As I was talking, our exterior wall is cavity wall. We are able to save upon a lot of energy transmission, which otherwise would have transmitted to the building through the external wall. We have a window to wall ratio of 40%, and as I told you, we have fenestration through which we are able to achieve 0.2 BTU per hour square per hour per feet square per degree Fahrenheit. We have dimmable and tunable lighting fixtures, as I've already explained, for color variation from 3000 to 6000 degree Kelvin, and the fixtures are glare free, and the ratio is less than 16. These are some pictures of the area. We have a solar PV installed for 100 kWp for solar power generation. Of course, we have installed building management system to manage all this, and these are some pics of screenshots from that control server, wherein we are able to monitor and control all parameters of a air handling unit, which mode it is working, and what are the energy consumptions. Similarly, for DG sets and all other things, site has been planned properly as per the rating. They require it to be within half a kilometer from marketplace and bus stop, which it is, because PGI is an institute wherein the all buses and they have a stand here, so no issues on that. We have an internal marketplace. We had adopted integrated design approach, as I was talking initially when I was discussing BIM, that all different facets, members from all different facets have to come together and discuss about their requirements of spaces and services. That's what we have already carried out. These are the shopping place and bus stop. Low emitting, another innovative measure which we have taken already is for low emitting vehicle, that is electrical vehicles. We have provided vehicle charging stations. Friends, if you have read today's newspaper in the Tribune, UK has announced that they would dispense with the petrol vehicle by 2030, and they would go zero energy by 2050. So it's a great leap forward, and all issues relating to pollution by consumption of oil and petrol would be dispensed with if UK is able to achieve this, and it will be an example for other countries to follow. As I initially explained, we have a universal design, meaning thereby even the lifts are open for a person with disability to operate, and we have requisite lamps and all those things. We have all measures concerning water conservation. We have rainwater harvesting pits, wherein we have utilized modular PVC containers instead of traditional concrete tanks. These are the modules which, when they are put together, they form a tank wherein the rainwater is collected, and geotechnical fabric is utilized here, which would give a shape of a tank. So this is our rainwater harvesting. This is the process flow. We have used green pavers. We have applied water conservation measures in cooling towers, landscape, and flushing. For flushing, we have two pipe system, and treated cooling tower we are taking to treated water we are taking to cooling towers. This we all know that water management requires reuse, recharge, monitoring, and metering. All these have been applied in this building. The fixtures are low flow fixtures with flow restrictors, as you can see. As against base case of 8 LPM, we have gone as low as 3.8 LPM. And this is with the aerators that we are able to achieve less flow without compromising on the functioning of the system. These are some more pictures. Landscape design I have already discussed. For this, we were awarded IGBC Platinum rating by IGBC in September 19. These are pictures of some other buildings, institutional buildings of the institute. As I have already shared, two of our buildings, first at serial number 1, which is Advanced Eye Center and Advanced Cardiac Center, where the first government buildings in government sector to have awarded ECBC rating. And now 250 bedded hospital is our third building, which is the first government hospital in the country to have awarded IGBC Platinum rating. So the smart hospital is what which saves energy, conserves water, helps in preservation of natural resources. This is the most important aspect I wanted to impress upon, that whatever infrastructure development we carry on, we must strive hard to preserve the nature and ecology of the area, to avoid situations like what we have in the country, specifically in Delhi, where the pollution levels have reached so high. It provides healthy indoor environment for patients as well as for staff, help reduce patient stay, as I've already discussed earlier, reducing operational cost. Once I am able to conserve energy and water, it will ultimately translate into lesser electricity and water bill. And of course, by doing or by applying these ratings, constructing a green building, we would be ready to be supporting smart city movement and to be a part of smart city. Thank you so much.
Thank you so much, sir. Amit, sir, you're there?
Dr. Amit.
In the meantime, participants, if you have any question, kindly please unmute your mic, or either you can type it in the chat box. So participants, do you have any queries? Participants, do you have any query?
Hello.
Haji Jaswinder Singh ji.
Haji, good afternoon, sir.
Haji Jaswinder ji, do you have any query? कुछ question कोई पूछना है discussion वास्ते?
Sir, is there any recommendations for color temperature for light fixtures for different rooms?
Saini Saab?
Yes, I was. Am I audible?
Yes, sir, you are.
Yes, as I was discussing, in different hospital areas, there are requirements of different color temperatures, specifically in operation theaters. If I am operating on a patient in gastro OT, I would have color temperature requirements of around 4000 degree Kelvin. Otherwise, in all other areas, we use lighting fixtures of 5000 to 5700 color temperatures, which would reasonably give us blue light. So the lower range you go, the color of the light goes from blue to yellow. The higher you go, it will go on whitish blue side.
Yes, sir. Thank you, sir.
So any other participant? So anybody else? From Tamil Nadu? Participants from Tamil Nadu, do you have any query? So I think everybody, I think there is no query. So I would like to thank Saini Saab for sparing his valuable time, because I know, sir, you are a very busy person, and you know, it is very difficult to spare some time for some like this academic programs. So, but we are very thankful to you that you have accepted our invitation at a very short notice. And I think all the participants benefited from your lecture, and it is a lecture in a holistic way. And I am also very much surprised to see the construction which you have done in PGI, because PGI is one of a very prestigious institution, and this Griha, this energy rated building is commendable work which you have done. So thank you so much, sir, for your lecture. And now I would like to request Dr. Sharma, Dr. Sanjay Sharma, to kindly say a few words. Dr. Sharma.
Thank you, Amit, and thank you very much for your sharing your expertise with the participants. And I think this is one of the say area where I think the and knowledge and expertise very little is available basically. I think like a hospital and one of the premier say area where I think we need to make our things smart. So that way, I think that this is a very is a required input given by you, an important input given by you. So thank you very much for sparing your time, and I hope that we will be having such interaction in future also. So thank you.
Uh, thank you, Mr. Sharma. I hope participants would have something to take away from this discussion. I would have loved it to be more interactive in physical form, but with the limitations of pandemic I hope some other time we'll interact. And this is the aim basically, as to share what we are doing here today, so that for other professionals who are in the field, may not be working in these areas, but maybe this is only to provoke thoughts on that direction, as you have rightly pointed out. Thank you so very much for giving this opportunity to me to be here and interacting with you. Thank you so much.
Thank you, sir. Thank you.
Thank you so much, sir.